everybody, in this video we are going to explore how to build an agent that builds other agents to do sales outreach. And we'll be doing this using LangGraph. The video will be a bit technical, I would say a lot technical actually. So you need to be a developer. And ideally you need to also have experience with LangGraph in the past because some things I may not cover too deeply. We'll be doing this in parallel, so I will run it, explain what's going on, and also show the source code. So before we jump in, an overview of the graph. We have different nodes, and almost every node is connected to the starting point so that the human can reply and give a feedback. We don't use interrupts here because the library I use on the front end, we use Assistant UI, which is actually super great, but they don't support yet interrupts, which LangGraph provides. So all the feedback we get from people has to always pass through the regular messaging feature it has. So every node is connected to the starting point so that the user can again reply, and every node, also almost every node, has a tools node because whenever the node is ready, it basically calls a tool marking that the node is ready, and then we move forward and so on. And we have different stages. So the first stage is to gather the requirements about the ideal customer profile and your offering. Then based on this, it creates a criteria of classification for the companies that match or don't match this ideal customer profile. Then it generates a message template to send to this. And then it also does additional keyword generation to properly find these companies and find the decision makers. And then it generates the search query. We use Apollo for that. This service. I think they're actually the best in this so far. If someone knows a better service, please let me know. We always wanna look for better stuff. And this query already has all these keywords, and then user approves the query. And once this is done, then the results are saved, and then we move forward to the other parts. But today we will explore only this part. And let's jump into the source code. So we wrote it on Python, and all the nodes I will just show in are located here. We've created a reusable function to create these nodes that call the tool node because this is a pretty frequent pattern for us. That's why we have it pretty often. And we will start from the first node, which basically gathers requirements. And I already prepared a message to make it easier for the demo. We will be targeting recruitment and staffing companies in France. So we just copy paste it. And it will start. It will already call the tool because we basically provided everything. We have all the information here. But if you go to the actual node, which is just here, you can see firstly the prompt. So that's what it collects, the basic information about the company. And we try to be as specific as possible about what has to be done. You can also just put on pause this video to read the prompt and so on. So the criteria of calling the tool is to get the minimum information we need. And once it is done, then it calls the tool. But because we provided everything, basically does it initially. But what I mentioned in the video initially, what you can do is to always call the tool and then just use the interrupts LangGraph provides so that you can do a proper human in the loop implementation. In our case, I didn't do this because the library I've chosen for the front end of this, which I was also showing on the demo of the sales outreach agent, where you can see how it looks and how it works. It just doesn't have this capability yet, but they will soon implement it. I created an issue like a month ago or something. So then we will be able to also use a human in the loop. But basically, it just collects everything, and once it is ready, it calls the tool. And for tool calling, we use structured tool, which also validates the schema of the data we need. And for this, we use pedantic or pedantic, whatever, which basically has all the specifications about how the stuff should work. They also had some issues at LangChain with the version. So I use the first version because the second just doesn't work yet with the structured tools. It was throwing some errors, and the guy suggested to use the first version. So there are some workarounds, but basically it works. And we gather the requirements here. Once the requirements are gathered, if you come back to the graph, it goes to the generation of the company classification criteria. And it happens once at this stage. This is because we always root back to the starting point. We need to have something which will indicate for our graph to where we should go after the starting point. That's why we also have a stage in our state which shows where else we need to go afterwards. I would just like the other idea would be just implementing a human node, but then this graph will not only have the tools node everywhere, but also a human node, and then it will be pretty messy. That's why what I've decided is to just always root to the beginning, and then from the beginning come back to each of these nodes again. So that's how it works. So this stage you can also see basically here. So whenever it's ready, whenever we have this tool call, which we take from the messages, we basically check out the history we have and look for the tool calls in the history. And once we find the tool call which has our campaign arcs name, then it means that we have this tool call, so we can proceed to the next stage, which is generation of company classification criteria. You can also see on the right that now this tool calling was done, and we move forward. And at this stage, it generates this is our state, the criteria, where you can see the positive indicators, exclusion indicators, and some sample classifications. This criteria will be used later on in our agents that will be created after we pass through all these stages. And it will be basically a part of the prompt where we will pass all of this, and based on this prompt, it will classify the company based on the company description. That's why we need also samples. But for the user here, it is a good way to review the criteria, be very specific about what kind of companies they look for. And for example, we can say that like for the first point, they use ATS systems, and we can say that, for example, it's not really mandatory. They may be not using ATS, for example, like applicant tracking systems. ATS is not mandatory, and we can exclude. And once we do this, you can see that you can see that it removed it from the number 5. Before we had the number 5, which was also ATS as a criteria, but now it is not mandatory. That's why it doesn't have it. We still have it in the samples because the sample was not only about ATS, but also about the senior level placements and so on. So this way you can communicate with the agent and give the feedback so that it will continue generating the criteria until you give a green light. And that's where we actually specified in the prompt. So if user requests the changes, we do this and then present the new version. And once they confirm, we call our tool to just put all this stuff. And that's actually where you can see also the instructions. So this will be the beginning of this prompt we will pass then in our new agent. So basically this sales agent, which is generated by this agent builder, I would say, will have two prompts. The first prompt is the company classification prompt, which will be always different for every ideal customer profile we create here every time. That's why it's basically a builder, because it will be always different. And the second prompt that we'll also have will be the message template prompt. That's how it will function. But we'll go to the message template prompt later on. Just wanted to show you quickly how this prompt looks like. And the interesting thing here also is that the only thing it uses is the company description. So everything we had in the state before is not really passed. So it's pretty minimalistic. Although we have lots of other things in the ICP, here we only pass the company description. This way we save on tokens. We also don't pass the entire history. What we basically do, we find the last tool call index of the campaign arcs, which was the previous loop we had, and we cut all these messages. So basically what this node knows is this message. where we say, okay, please generate the classification criteria. We pass the description into the prompt, and it already outputs the criteria, but it doesn't know neither this nor all this information we passed. We basically cut the message history from this starting point. And this way we also save on tokens so that every node here is localized as maximum as possible. And if we come back to the gather requirements, what it also does, we basically, when we go to the next node, we already pass the message from a human, quote unquote, where we say that we need to generate a classification criteria based on the description. This way they kind of communicate with each other and they go from one to the other. The other option you can do, if you don't want to have this kind of an interactivity, you can just do these all calls in parallel because they all depend pretty much from this initial call. So once you've gathered all the requirements, basically all the rest you can do in parallel. But in this experience, I wanted to have it more of a like multi-step form when you need to go through every step yourself and just like read through this and confirm. But if you want to make it like completely autonomous and maybe give a human a way to change it afterwards, what you can also do is to run all these things in parallel, collect, aggregate everything, and then just give a human a React agent so that with this agent, the human already can act on different parts of the state and improve. That's how you can also do this. But in this example, it's done this way. So once we are happy with the criteria, we say, okay, that's fine. We say it looks good. And it goes to the next node. These are the instructions. As you can see, it replaced it with a business list instead of the variable which was there. So it's kind of adjusting the instructions based on what was given. And now it generates the message. For the message generation, first it wants to ask the name and the title of the sales person on behalf of whom this message will be sent. And if we go to the generate message template, we can see this in the prompt. So first it requests this information. Once this information is requested, we've got an answer, then we generate the initial template, we present it to the user, and then once the user approves, we call our tool. The interesting thing here is that it's also a prompt that generates a prompt. So when we generate a prompt, we basically explain how this prompt will be used. So we say that, let me actually quickly just show you the message so that you can also be a bit more specific. So this is the message. You can see that the first name is a variable, and you can also see that the description, the message itself is kind of referring to specific challenges from a company description. And so this will be a part of our prompt. And this thing will be passed afterwards together with this, where the company description will be specified and the name of the company is the name of the person. But basically, because it knows that the company description will be a part of a prompt with this template, it will then also replace this with something more coherent with the whole sentence. For example, if the company is doing recruitment of Golang developers, you don't really have that many Golang developers because it's not that popular. It may say that it's pretty hard to find Golang developers nowadays, and it must be frustrating for your team's productivity and so on. That's just an example. So it can be pretty specific based on every individual company description, and that's what we specify in this part of the prompt. Which is also interesting, we have the structure of the message, so it will be always built this way. It's problem focused. We start from a 3-word question reflecting the key pain point. That's how the subject is formed. Like all these best practices, that's how the outreach guys are doing outbound at the moment. That's just like how it works. So we just teach our agent to do the same way so that we are as competitive as all the humans, but without any human involved. And then after user approves everything, what it also does, it validates our template as per each of these points. This way we kind of enforce the LLM to also self-correct if something is wrong. And we can also see that this check is on here. So, okay, let's say we can also just give feedback, but then the video will be pretty long. So we say just looks good. Yeah, also the message history is again cut. So from the company classification to column onwards, so that in this case, what we also have is a limited history. The only thing here we pass the entire state we have about the company, the campaign, which we've gathered during the first node. That's why this one is a bit bigger, but at least we don't pass the entire history of our conversation, so that it's kind of also lean in token consumption. We also do a small login here because the service has to be GDPR compliant. So as we pass the name of the person here, the business development person, they kind of process their personal data. That's why we need to put it in auditing here every time when it's called. What you can do also is to check if the name was actually passed and only do this login when the name is passed. But for this demo, I didn't do this that complicated. So it always creates an entry every time that this node executes. And while I was talking about this, you can already see the next stage. So the next stage is the keyword generation. And this keyword has two types of keywords. These keywords will be already used for in Apollo search. So it has to, like the company description has to have one of these keywords, and it shouldn't have these keywords. So it shouldn't be a software company, it shouldn't be an applicant tracking system and so on, but it has to be a recruitment company. And you can easily extend this list, for example, by just typing generate more. And if you go to the prompt, you can actually see how it's built upon. This part, I was just playing around with interactivity. When I want to test it all, for example, if you want to use Brain Trust or any kind of other services to just evaluate how well our prompts are, or our agents even are performing, we want to disable interactivity so that it all just works from the first step without asking the user for the feedback. And that's why I have this flag here. If you come here, you can see the actual prompt. So I try to be as specific as possible with the keywords, not having lots of overlaps, because usually the problem with this kind of keyword generation, sometimes they may put like recruitment firm, recruitment consulting firm, blah, blah, blah. That's what you have by default when you ask for these keywords, especially when you use OpenAI models. That's why here we also use Anthropic, by the way. In general, like for keyword generation and also for the message generation, for classification criteria, everywhere we use Anthropic, Claude 3.5, because they're just better in doing this as per my experience. If you would do the same with OpenAI, they will generate pretty messy keywords and it's pretty hard to make it work the way you want to work. So it's just better at reasoning, at least for these specific tasks, as per my experience. So here you can see that it only generates the keywords which are kind of unique without repeating itself. And it's always specified in these rules. And below you can also see like an example. The way we teach this prompt was also based on recruitment agencies, but you can do this pretty much for any kind of a vertical, and it will always do pretty well on keywords and the anti-keywords. So once this is done, we can say that it's also fine. And by the way, why we have this two node, what it does, basically, if it will hallucinate and do a tool call with a corrupted JSON, it will come back to our node and try to re-execute many times. That's basically why it is here. And once this is done, it then generates the job titles of decision makers. So in this case, the people from operations or from technology, because we want to sell them a digital tool. And if you go to this part, you can actually see how it works. So pretty simple prompt and nothing special here. The same way we also just pass a part of the data which is relevant for this prompt and so on. So you can just move on. And once it saves this, it goes through the next two nodes. And here it does it completely autonomously. We can't really be involved here. No need. And in these nodes, while it's doing this, let's just go there. So first it translates the keywords based on the languages of the markets we are looking for. So it takes the locations, and based on these locations, it gets the languages which people are speaking, and it returns the country codes. And we only do this for non-English languages because English will be included anyway. And these language codes are later on used to generate keywords, anti-keywords, and job titles. Not the ones we've just generated, but basically translate them on these languages. And if there are no other languages, if it's only English, then we just keep and go straight to the next stage, which will be our Apollo company query generation. But if it is not the case, what it does is translating all of them in parallel. So we speed it up a bit using asyncio, asyncio, whatever. And it does it for keywords, for anti-keywords, and job titles, all in parallel. It does it in batches. So in this case, it's 10, but we can easily make it much longer. That was just for the demo because the models are pretty capable. But basically, it translates all of them in parallel. And if we look on the state now, it's actually finished. You can see that it added range keywords here. And this way, we do not only find the companies which use English keywords, especially in France, it's pretty complicated sometimes, but also the French keywords. And this way, you'll definitely find everyone in the local markets because we tackle their descriptions in French as well. Same for the anti-keywords and for the decision maker job titles. So you can also see all the possible variations. This way, our search will be pretty precise. But let's move on. Now it is already at the latest stage, which is Apollo company query generation. And here firstly, it also went through the second node, which was our just generation without approval. And the interesting thing here is that it maps the industries we've got from our ideal customer profile into the IDs from Apollo. And we pass it as a part of the prompt so that it would basically return us not even IDs. We put these like more like user understandable names. So to basically map, for example, computer software like this long text, enterprise software development, IT consulting into like proper names of Apollo industries, which are computer software and so on. So we kind of map the terms into the terms of Apollo so that they will be used as filter values later on. And we also map all the other things we've got from our keywords, anti-keywords, also revenue, locations, and so on. We map this all into our long Apollo query. And then it goes to the next stage, which is approving this query. So the approval works the way so that you can see the query. You can go there and see how this all looks like. So you can see the keywords, this is the industry, and so on. So you can play around with it. We can, for example, remove the revenue, because not every company has this information on Apollo. You can remove the industry, because not every company will specify it. Sometimes they just use keywords, and you can already see that from just like 14. Now you will get much more. You can also remove regions. Once you're happy with that, you just go back to Apollo and say, okay, let's remove revenue industry. And it will do the same for this query. And if you go forward, by the way, one thing I forgot to mention is that all the JSON outputs we got from the models, we also validate with a library which kind of reconstructs corrupted JSONs. For example, we do this with the keyword translation. And this library is named JSON Repair. Highly recommend. You can also use LangGraph, which has more stuff to kind of sanitize your inputs and outputs for many things, also saving you from jacking and so on. But in this demo, we don't go that hardcore. We just make it a bit simpler for the audience, but you can also use it to really make it production ready. So it's updated the query. Now there is another one. If you go to the approval node, how it works, we also explain the structure of the query, how it should behave. And the interesting thing here also is that we validate the query very deeply in the actual model we have. So we specify what kind of parameters there should be and so on, because sometimes it also hallucinates and does not output everything we need. That's why, oh, I've been working a lot. Okay, so basically that's how this works. And once the query is fine, we can say looks good, and it will save everything. So this is the end. It will go and save everything into our database and call a cloud task to basically run the campaign. And in the other place, it will create this agent, which will basically have these two prompts I was mentioning, the message template generation prompt and the company classification prompt, to already look for the companies using Apollo, passing this filter, taking all this information, classify the company, and if the company is okay, then look for the person, decision maker by the job title I was mentioning there, and then to generate the message template based on all the data we've got. So that's how it works. And thanks for watching.